Hello and welcome to Uncle Matt's Online Academy. Today we want to talk about the principle of flotation, and this is going to be our last lesson or our last discussion on density. We've talked about the meaning of density, different ways to determine density, and relative density of liquid, solid, and powdered substances. And we've done a lot of calculations involving density. We've also talked about the upthrust, relative density, and Archimedes principle. So today we want to look at the principle of flotation, and we are going to learn how this principle allows us to know why ship floats and the principle behind the instrument used in measuring density, which we call hydrometer. The principle of flotation is actually stated as, or it states that when a liquid is totally or partially immersed in a liquid, when an object is totally or partially immersed in a liquid, that it will displace amount of the liquid that is equal to its own weight. When a solid is immersed in a liquid, or when an object is immersed in a liquid, it will displace an amount of the liquid that is equal to its own weight. That is the statement of the principle of flotation. Now, the amount of liquid displaced by an object is always equal to the upthrust according to the Archimedes principle, which we talked about the other time. And so we can now say that for an object to float in a liquid, that its weight must be equal to the upthrust. The weight of the object must be equal to the upthrust. So if we call the weight of the object W, this must be equal to the upthrust U. So this is the principle of flotation. This weight, the weight and the upthrust must always be equal for an object to float. And I don't know if I've ever wondered if an object that floats in one liquid will also float in another liquid, or if it is a must that an object that floats in one liquid will also float in another liquid. Now, this is a very nice question to ask, and the answer is no. An object can float in one liquid and will not float in another liquid. The reason is because of the upthrust. The upthrust in different liquids are different. You know that I said that upthrust is the force that is opposing the weight of an object that is going down in a liquid. So if we have a liquid like this, and we have an object coming down to it, then I say that there is an upthrust U that is acting opposite to the weight of the object. So the weight of the object is coming down while the upthrust is pushing it up. Now this upthrust is different in different liquids. Some liquid they have big upthrust or large upthrust, while others they have smaller upthrust, which means that if they have small upthrust and a liquid with big weight like ship is put in them, then the object will sink in it because the upthrust is not enough to equate the weight of the object. The weight of the object and the upthrust must be equal for the object to float in the liquid. So that is it about the principle of flotation. They can decide to give you small calculation in this principle of flotation. They may tell you that the weight of an object that floats in a certain liquid is 50 Newton. Now you should calculate the upthrust in the liquid. Now, since we know that weight is always equal to upthrust, now if they say that the object is floating in the liquid, it means that the weight of the object is also equal to the upthrust. That means that the upthrust is also equal to 50 Newton. If they say that the weight of the object is 10 Newton and the object is floating in the liquid, it also means that the upthrust is 10 Newton. In another way, if they say that the upthrust in a liquid is 5 Newton, that you should calculate the weight of the objects if the object is floating in the liquid. You don't have to do much calculation here. Since the upthrust is also equal to weight, we now say that the weight is also equal to that 50 Newton, which is the weight of the object. So whatever amount they give you as the upthrust, it will be equal to the weight of the object, and whatever amount they give you as the weight, it will be equal to the upthrust, and vice versa. If they give you weight, you equate it to the upthrust. If they give you upthrust, you equate it to the weight. Now, I said that we use the principle of flotation in designing what we call hydrometer. That is the instrument we use in measuring the density of liquid. We call it hydrometer. Hydrometer. Hydrometer, we have two types of hydrometer. We have a simple hydrometer and practical hydrometer. Simple hydrometer, which you can make with your test tube, simple hydrometer, and practical hydrometer. In simple hydrometer, what you do is that you get a test tube in your lab, put some lead. Lead is small iron. There is a type of metal called lead. It is always very heavy. You put small amount of it in the test tube and place it in a liquid that you know is density, maybe water. Then check the level that the test tube will flow to. Assuming any level that it flows to, you mark it 1 because the density of liquid is 1000 kilogram per meter cube or 1 gram per cm cube. So you can name it 1000 depending on the unit you want to use. You mark it, then you place it in another liquid of that you know is density, and then you mark it. When you mark the two level, then you can be using the two level you've marked to get the density of other liquid. Assuming that you have that of water 1 here, and then another liquid of maybe say 5, this one 1000, let's say this one is 5000. So if you place it in another liquid and it gets to this level, there is a way, small calculation you will do, and then you'll be able to determine, using these two, you'll be able to determine this third amount, that is the value of x here. So we are going to learn how to do this later. Now this is it about simple hydrometer. I'm just trying to describe what is meant by simple hydrometer, that you don't need much things to create a simple hydrometer. Just your test tube and lead, and you place it and you put it in a liquid of a known density, two liquids of known density, and then from that you can calculate the density of other liquids. Maybe when you have created these two, then you can now use your ruler to measure the distance from this place, from 1000 to the 5000, and then create equal marks from each of them. Then maybe after each 1 cm, you name it. Maybe this one is 2000, this one is 3000, this one is 4000. You create equal interval between them, so that when you put it in another liquid, you see the interval that it has gone to, and then you'll be able to use your ruler and calculate it. So that is it about a simple hydrometer. Now, looking at this thing, you can see that I numbered the 1000, that is the smaller value at the top, and the big amount, which is 5000, below. Yeah, that is the principle. That this is because of the principle of flotation. The principle of flotation is telling us that the more the upthrusts, the denser the liquid. A liquid that has more upthrust will be more dense. That means that it will resist the movement of an object down to it. Assuming we have a liquid A and it has big upthrust, it means that it will be very, very dense. A dense liquid does not allow substance to sink very well in it. That means that if you place a hydrometer in it, the hydrometer will sink very, very small. And so for you to determine its density, it that shows that the liquid is very dense. It means that the highest point is going to be almost at the bottom of the hydrometer, while the smallest amount will be at the surface of the hydrometer. So if this liquid is less dense or not very dense, then it will sink very well, and so it will get to the point of almost zero. So that is the principle of flotation, how it works with hydrometer. The denser the liquid, the more the hydrometer will sink, and so it will get to the point that will correspond with less dense liquid. A less dense liquid, let's say that the density will be 1, but a liquid that is very dense, the density will be, let me say, 5. So if you number it 5 here and this place 1, assuming we want to do it this way, the top 5 and this place 1, it means that if you place it in a dense liquid, it will sink and become 5 here, which is not what it's supposed to be. If you place it in a very dense liquid, it will not get to that 5, because the hydrometer will not sink, and so it will pose the principle of flotation. So for you to make sure that it gets to 5, which represents high density, then it means that you have to place it at the bottom, so that if you place it in a liquid that is very dense, then it will be able to reach that highest amount. And if you place it in a liquid that is less dense, then it will get to maybe 0 or 1, the lesser that correspond to less dense liquid. So that is it about the principle of flotation in hydrometer. Then another type of hydrometer is the one we call practical hydrometer. This is the one we use in experiments, a very practical one, like the one that you buy in the market, or the one you use in a very serious science experiment. The principle is just the same thing. You calibrate from top. So this one, instead of using a test tube, this one is well designed, and then every mark is calibrated. You don't need to use ruler to get the mark of the density of the substance you have measured. This one is well calibrated, so once you put it, it will get to the point of the density of the substance you want to measure, and be able to read it directly. So that is the difference between the practical hydrometer and simple hydrometer. So with this, we have come to the end of our discussion on density. We talked about the definition of principle of flotation and how it relates to why objects float in liquid, and then how it is used in construction of hydrometer which is an instrument used in measuring density of liquids.